Alright, so I'm here to double check this guy's work from the Warren's Dunes Hill to Chicago Sears Tower, and I'll just kind of play some of his videos and then I'll go into my results. So we can. So this is the top section, which is the 90th floor, because there's 3 sections. So the 90th floor, I think when he was shooting, I think he was thinking the 60th floor or 66th floor. I think he was shooting up here when it's actually 90th when he was shooting. But that's in the other one, not this one. So then this says, take a measurement of the vertical angle to the top of the tower with a theodolite. If the Earth is spherical, you will get -7 to 8 degrees. Okay. If it was flat, you get 1542. Okay, so here's my little spreadsheet. 1542, he said, and -7. -7, 8 seconds. And the thing is with my information, there's no refraction, there's no perspective. So we're in the same range. So the top of the tower I get -1528 and he got 1542. So I mean that pretty much matches. What's this say? Well, 10K, yeah. I didn't get a greater than 1542. I don't think. 1528. So. Alright. So on this part, you would see all 3 sections. on this model. And then on the what's actual here, what we live on is you would see the first stage plus the distance times 1.33. And that's pretty much what I get. So he got his little sections. So he got 53 miles and 15. I don't know what I got on my section that I kind of drew up here real quick. So I got 53 or 52 across the lake from shore to shore. And then I got 1,700 feet from the shore to where he's at. And he got 1,500 feet. Well, yeah, because he's sitting right here. I'm from the shore, so mine's a little longer. So he went to the center of that. Okay. So I did it the other. I went from shore to shore and then out. So on mine, that blue line's the shore, so it's 1,700 feet there on that side, and then 1 mile from the shore to the Empire or Sears Tower is 52.81 a mile. So 52, 53 plus that, so it's yeah. So back to, I think we're pretty much done with this one. Now we can go into this one. So he's reading 731, which I got 731 on the top of the tower. -13 to the horizon. So the 66th floor, he's got that one wrong. I will guarantee you that, because is how I know is because the 66th floor is right here. It so the 66, it says 66 right here. And it's pointing to that pad right there. Up here is the 90th floor, 50th, and 30th. And then 110. So he wouldn't be shooting that because it's right here. I mean, he wouldn't be shooting clear down here. He'd be shooting. He's over here shooting across to this point. So that's how I know. So I got it lined up exactly how that view is with Google Earth. So that point there is that point. It's lower. Still in a way it could be. Seems like this one should be down here or something. So that's lower and that's higher. And there's 3 of them here. So there's 1 there, 3. 1, 2, 3. It's hard to tell, man. I know this is the 90th floor. So we need this here. This I'm not. That number should be up here. The antenna thing should be up here. Maybe not. I don't know. But what I get, so with my stuff, so like this elevation that where he's at, that top of that yellow line is at his theodolite height. And if you draw a straight line straight over, that's how much of the tower you will see. Pretty much the whole thing. So I did my I took the elevation 595 plus the height minus the water level, and I got 1470 feet top of the Sears Tower from the water. So that's what that 1450 is. And then on the other side, you take 778 because that's his height minus the water level, 197. And then the water level is not flat on both sides, according to Google Earth. So on his side, it was 581, and then on the other side was 575. I mean, it could be 581 too. I don't know, but subtract those, I get 6. So then I take 1470 minus 19 or 197, which subtracted that number from that number, and then minus 6, which is 1267. So, and that's what that number is, 1267. From that line above is what you can see if it was flat. Okay, so here is my drawing from, here's the globe with the radius of, what, 39 59 miles. So, so here's my horizontal tangent line. So that arc is 53 miles long from to over here, and this is his deal here going on, which is almost 200 feet, 197. And so then, like if I draw a line from here, I go tangent, and extend it, which I've already done this, but I'll show you. Let's see, green maybe, I don't know. It's hard to see it. So it will strike that line right there, because that's the horizontal line, or the horizon line. So I don't think you'll quite see half of it, but you will see, because that right here is half. And here's the top section. And so down here, so if I take that and then times it by 1.33, it's pretty close. And it strikes it right there. Which is 1450. That right there. Or 1470. That's to the, there's 20-foot difference. From the shore. Because I used 575. So that's why I got 1470. So, So if I take, it was hard to determine the 90th floor. But if I draw a circle from here to here, and then take that, because this drawing's in meters, so paste it times 1.33 equals, so 108. So I'll drop that sucker down, and I'll say 108. So it's, the horizon's right in here, between here and here. So if I want to get critical about it, I missed it by maybe, what's the radius of that? So 7. So 7 meters to feet. So 20 feet. I don't know. I'm not there to see the horizon, so I don't know how tall. I just know it's somewhere within here. And that's not halfway. So halfway would be, well, I guess if I do that, let me see, hold on. Draw a line from it's still not halfway, so that this guy right here, right there, is halfway. So it's you won't see half of it. Pretty close. So my tangent line, so then I just drew, of course, my tangent, just a line perpendicular to that line. And then I extended it from that point, and so that's how I got that green line. Then I come over here to this is just drawing it. Okay, this is just, and then this is drawing it for the flat earth stuff. And here's my actual data with coordinates. So so to the top, I don't even know if I get this filled out right. So to the top, I got 4, 6, and to the antenna, and then, well, the horizon, I'm not too sure about that, so hello. So 14.6, and then to the top of the tower, I got 731. That's pretty consistent. Negative, so they're. So when I do this, it's actual. It puts it with the coordinates. I have uh, like if I open up this survey, I don't know why that's not. These are actual points, so I cannot. These come in as a Kogo point in Civil 3D, so I don't. They come in how they are. I don't do nothing to them. So I'll open this up. Jesus. So here's my, go to properties. I can look at my file. So here's my points for the coordinates for the sand hill where he's at, standing at. So, and then I already had these in there from Jesse. So, so that's where this is, right here. On the globe. And so I've drawn other stuff, distances, the arcs, and it fits pretty nicely. But we can listen to him some more, I guess. See that top?
So it's Sunday, October 25th, here at beautiful Warren Dunes State Park. We have an absolutely clear day, a good day for taking sights, probably 50 or 60 miles of visibility on this day. I'm at elevation 778, top of Tower Hill, near the NGS survey station, Bald Tom, but not at that station. And based on WGS 84 spherical Earth, we would expect to turn an angle of negative 14 minutes to the horizon from this point, and an angle of negative 6 minutes to the top of the Sears Tower from this point. And so I've just turned those angles. I come up with, to the horizon, I come up with an angle of negative 13 minutes and 40 seconds, which is very consistent. That's to the horizon. And then to the building, I'm getting 7 minutes and 32 seconds and 3 minutes and 47 seconds, which I will digest that information and put it on the video clip. But this is very good weather, very good date for doing this, and seem to be having very good results. From this location, you can confirm.
Yep. So mine pretty much matches what he got. I think he just got a little mixed up on that 60th floor. It just kind of just doesn't 66th floor. Where is that? That just does not seem right. That 66th floor is not negative. It's just not, man. Because 90th floor is up here. And that's what you're going to shoot. You're not going to shoot to here. So the 51 to 66 goes from here to here. I mean, I don't know what more to say. That's the 66th floor right here. Here's the 90th. And here's the 55th or 51st. So, and how I got my elevation for the height, I guess I used the 103rd floor. So I kind of did an estimate of 13 13.13 feet per floor. So that's kind of how I got mine, to see if I was close to the horizon, which I was off, 20 feet or 10 feet. I mean, I don't know exactly, but that's pretty good for 53 miles. So, because I don't really know exactly what this distance is. So I'm always kind of guessing. I wasn't guessing because I drew it. So if I set my UCS, where's this damn thing? Oh, I can't even probably find it. I think it's that green line. My tangent line. So this line goes to the equator. This line goes to the center of the Earth. And that's my tangent line to the center of the Earth. So I got my 3-point UCS. get back in my view where I was. I'm gonna go to, because that green line's 5 feet, so end to that green line. I'm back where I was. So I was guessing on the height of this to what he used, 1.33. I didn't guess on that because I drew that line to the radius, the tangent. So, which I got 14.55. So, and if I trim those out, computer's acting goofy. I don't know. Hey, it's weird. You just did the whole thing, didn't you? God. I think I've had it running for too long. I don't know why it's Jeez. It was up there. See how it moved? It didn't move, it's just the regen. Jesus. It's lagging big time. So if I take that arc distance, finally, just to show that I could have stopped a long time ago. Meters to feet or miles. So 53.33. So, yep.